How can Venus keep an atmosphere if it has no global magnetic field? Venus has no global magnetic field, and yet it has a very thick atmosphere. But how is that possible? After all, we've been told that Mars lost much of its atmosphere partly because it has no global magnetic field. And if that's true, then why does Venus get to keep its atmosphere? Well, there are three main reasons. First, while a magnetic field can protect a planet's atmosphere from being stripped away by the solar wind, it's not the only thing that matters. In fact, Venus is losing atmospheric particles today, but compared to Mars, it has a lot more atmosphere to lose. Venus's atmosphere is mostly carbon dioxide, and the surface pressures at Venus are roughly 90 times that at Earth. Mars, by comparison, is very tenuous or very thin, and its surface pressures are less than 1% that of Earth's. So even though both planets are losing atmospheric particles, that loss has a much greater impact on Mars than it does on Venus. It's the difference between slowly draining a swimming pool versus slowly draining a puddle. The same process is happening, but the impact is a lot different. The second reason that Venus gets to hang onto its atmosphere is due to its size and its mass. Venus is much more massive than Mars, and so the particles in its atmosphere have to reach higher speeds in order to escape out into space. On the other hand, Mars' smaller size and lower mass means that it has a weaker gravitational pull on the particles in the atmosphere. And so that leaves them more subject to being accelerated by the sunlight or to being washed away by the solar wind. The third reason that Venus gets to keep its atmosphere is that it's actually not completely unprotected. The solar wind also carries its own magnetic field, and when it reaches Venus, it interacts with the electrically charged upper atmosphere in a region that we call the ionosphere. That interaction creates electrical currents, and when you move electrical currents around, they create magnetic fields around the planet. This is what we call an induced magnetic field. It's not the same as an intrinsic magnetic field that's created in the middle of planets, but it is still strong enough to divert and slow down the solar wind. The induced magnetic field is not enough to stop the solar wind entirely, so it still does strip away some of the atmospheric particles of Venus's upper atmosphere, and this includes hydrogen and oxygen, which may explain why Venus has lost the water that we think that it once had. Venus and Mars are affected by many of the same types of processes, but they have very different outcomes. Venus has far more atmosphere, and it's also larger and more massive, and it has a charged population in its upper atmosphere that interacts with the solar wind's magnetic field, and that produces an induced magnetic field, which helps protect it from the solar wind. So while a global magnetic field is certainly important to the survival of the atmosphere of a planet, it is not the only thing that matters when it comes to interacting with the solar wind.